Hey guys, so today we're going to try to solve this problem here. So we have 2 over 2 squared minus 1 plus 2 over 3 squared minus 1 plus 2 over 4 squared minus 1 plus, wait, that's a dot dot dot. That means there's infinitely many terms. I don't know about you, but I don't want to just sit here for the rest of my life adding fractions that don't even have the same denominators. If only we could just get rid of some of these terms. If only there was subtraction. I mean, we could just get rid of a lot of them. But that doesn't seem to be that helpful. Well, something I do notice is all the numerators are the same. They're all just 2 over something. That's interesting. And something else that's kind of interesting is all the denominators also look the same. They're just something squared minus 1. I'll just use a variable to write that. So I'll just write n squared minus 1. So if you notice, all of these terms are just something like this. We have, in the first one, 2 squared minus 1, where n is 2. Here, n is 3. Here, n is 4, and so on. But hey, look at this. I actually recognize this. This is a difference of squares. That's a factorization technique, and we can actually use that to get 2 over n minus 1 times n plus 1. Now hey, that actually lets us break the fractions up. So check this out. You can write 2 over n minus 1 times 1 over n plus 1, or maybe 1 over n minus 1 times 2 over n plus 1. Well, let's just try the first one. Well, here we get 2 over, in the first fraction, we get n is 2, so 1 times 1 over 3. I'm just plugging in 2 here. And then we get 2 over 2 times 1 over 4, and 2 over 3 times 1 over 5. And then our really painful dot dot dot. Well, this doesn't seem to help. The only problem is, well, we do have some repeated denominators. That's really nice to see, and the denominators are really easy to work with. We don't have these squares, but there's multiplication here. We can't really easily combine the multiplication and addition. It's kind of hard to work with. So, you know what would be nice? If only we could write 2 over n minus 1 times n plus 1 as some sum of fractions. Like maybe a over some number a divided by n minus 1 plus some number b divided by n plus 1. That would be really nice. The only problem here is finding a and b, but actually we might be able to do that. Look at this. Let's multiply both sides by n minus 1 and n plus 1. That way we can get rid of the denominators. And you see, we chose the denominators to be the factors, because when we add fractions, we multiply the numerator of this one by n plus 1, and the denominator also by n plus 1, so the common denominator would be n minus 1 times n plus 1. So let's just try to multiply by n minus 1 times n plus 1, and when we do that, check this out. The n minus 1 and the n minus 1 go away, and this n plus 1 and this n plus 1 go away. And both of these go away in here. So we get 2 is a times n plus 1 plus b times n minus 1. That's pretty nice. Hey, now look, if we sum these, or evaluate, or expand, we get an plus a plus bn minus b. If only this a and this b, this a and the bn could just cancel out, because there's no n's on this side of the equation. So maybe if only a plus b was 0. Well, we want this a and the minus b to add to 2, so maybe if this a minus b could be 2, that would be really nice. If both of those happened, well, this equation would be true, and we could just plug in a and b here and get a perfectly nice equation. But hey, we can actually do that. If we add these two equations, we find 2a is equal to 2, so a is equal to 1, And that means b is also -1. That's pretty nice. Because look at this. Our wishful thinking actually worked. Now we have, well, I'm going to get rid of all of this. Remember that a and b were 1 and -1. So if I get rid of this a and replace it with 1, and this b with -1, look what happens. When we combine the fractions, we get n plus 1 over n minus 1 times n plus 1, plus -n plus 1, if we multiply this by n minus 1, and n minus 1 times n plus 1. Now these have the same denominator, so that's nice to add. And look at that, the n and the n cancel, and the 1 and the 1 add to 2. So we get 2 over n minus 1 times n plus 1 is equal to this, which means it's also equal to this. And look at this. Since these are equal, that means that 2 over n squared minus 1 is equal to 1 over n minus 1 plus -1 over n plus 1. Now that makes things really nice because remember, this fraction here is just this when n is 2. So actually we can write this as 1 over 2 minus 1 plus 1 over 2 plus 1, 1 over 1 plus 1 over 3. And this one is 1 over 3 minus 1. Actually, this should be a minus because the -1 over 1 over 3 plus 1, which is 4. And we get 1 over 4 minus 1, minus 1 over 5. And we can see the pattern, 1 over 1 minus 1 over 3, 1 over 2 minus 1 over 4. Well, next is 1 over 4 minus 1 over 6, so on, so on. But hey, look, if we take the positive terms and we take the minus terms and we single them out, we get 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus so on. And then we get minus 1/3, minus 1/4, minus 1/5, minus 1/6. And look, the positives and the minuses cancel out after 1/3 because for every positive fraction, there's going to be a negative fraction that comes up. The only things that are remaining are 1/2 and 1. Well, if we want to see this really clearly, remember that the positive fractions are just 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus so on. And the negative ones start with -1/3. So we have -1/3 minus 1/4 minus so on. And we add these, so all of these just cancel out. And we're just left with 1 over 1 plus 1 over 2. And, well, that's not too hard. I was opposed to doing infinitely many fractions, but I can do finitely many. 1 plus half is just 3 halves. That comes out to be our answer. So the way that we did this is we actually broke this fraction up into tinier, easier to deal with fractions and had some subtraction and got this 3 over 2. We got rid of infinitely many of the fractions. Now, this technique that we use here, this actually has a name. This is called partial fraction decomposition. So that's basically it for today. I hope you learned something and see you till next time.